Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video I'll show you how to perform object tracking using YOLOv9 algorithm and ByteTracker. So first we will detect the objects using YOLOv9, which is an object detection algorithm, and after that we will send those detections to the tracker to track those objects in the next frames. So guys, in my previous videos of YOLOv9, whenever we want to use the YOLOv9 algorithm, what we did, we first cloned the GitHub repo of YOLOv9 and then we install all the requirements, right? This is how we use YOLOv9 algorithm. But in my today's video, we will use a different way to install the YOLOv9 algorithm. So Ultralytics, they recently integrated this YOLOv9 algorithm in their Ultralytics package. So today we will use the YOLOv9 algorithm through that Ultralytics package. So that means there is no need to clone the GitHub repo of YOLOv9. We will simply write pip install Ultralytics and our environment will be ready to run the YOLOv9 algorithm and the ByteTracker. So let's start today's code. So this is a Jupyter notebook. So guys, this is how you install Ultralytics, and after that we are importing YOLO from Ultralytics, and here we are loading the YOLOv9 pre-trained weights. There is no need to download this pre-trained weight manually. So when you'll execute this cell, you will automatically get this YOLOv9c.pt weight file in your current working directory. Earlier in my previous videos, we have to manually download these pre-trained files, but now there is no need. So using this YOLOv9 pre-trained model, we want to perform detections, and this is the video 14.mp4. This is the path of that video, and on this video we want to perform predictions, and save true will simply save your results in runs folder. Let's execute this cell. Results are stored in predict5 and it is a detect and then in runs folder. Let's open this folder and see the result. So here is the runs folder, and this is the Jupyter notebook which I'm using, and see, this is the weight file which get downloaded when I executed this cell. Okay, so when I executed this cell, what happened? First, this weight file, we get this weight file in our current working directory, and then from this test videos I tested on this video, and we get this runs folder. Inside that, in predict5, let's see the output. So here you can see that we are detecting all the objects which are there in Coco dataset, right? So this is how detection works. Now we will perform the tracking, and I'll show you the output of tracking on the same video. To perform the tracking, you just need to change this one thing. Earlier we used model.detect because we want to perform the object detection, but now we want to perform the tracking. So for that we are just writing model.track and provide the link of the video, and this is the model which we want to use for detection. YOLOv9 will detect the object, and then we will track those objects using this and the further frames. Okay, so this is the same video. Save true will save the output, and then let's run this code. And results are stored in track2 folder. Now let's go to the track2 folder, runs, detect, track2, and let's open it. Here you'll see that for each detected object we have a ID, and we have different IDs for different objects. So this is how you can perform tracking using YOLOv9 and ByteTrack tracker. Here with the help of Ultralytics we perform detection and tracking very easily. Otherwise, if you want to use the traditional way, let's say if we want to detect and track the objects without using this Ultralytics package, then how we will do it? First we will clone the GitHub repo of YOLOv9, will install the requirement of that, and then if after that you will see that which tracking algorithm you want to use. Let's say you want to use ByteTracker only, then you will clone the GitHub repo of ByteTrack also, and then you'll install the requirement of that ByteTrack tracker. After that you will make some modification to use these two algorithms together, but here we can do it easily with the help of Ultralytics. So guys, this is how you can perform object tracking using latest YOLOv9 and ByteTracker. Till now we have learned how to use pre-trained YOLOv9 model and then how to perform detection and tracking using it. Now guys, I'll show you how to train YOLOv9 on custom dataset. So first let me show you the dataset which I'm using. This is the dataset. So we will detect fire and smoke class, and you can download this dataset from RoboFlow, and just click on this YOLOv8 and then click on this download zip file and click on continue. You will get a zip folder in the downloads folder of your PC, and then from there you can use it. Let me mention the link of this dataset here. So this is the dataset link. You can download this dataset from here. We have two classes in it, and here we have defined the data.yml file. So data.yml file is very important because this is the file which tells your algorithm about your dataset. And I want to train my model for 100 epochs. And now let's see this data.yml file. So here is my data.yml file. Let's open it. Here we have given the path of training images. This is the path of validation images, and this is the path of test images. Number of classes are 2, and these are the name of those classes, fire and smoke. Now let me show you the dataset. So my dataset is here. So the Jupyter notebook which I'm showing you is here. Data.yml file is here, and this is the custom dataset. When you will open, you will get these 3 folders. Under train you have images and labels, and labels are in text format because this is how YOLO model accepts data, right? So for validation also you have images and label, and for test data also you have images and labels, and you can get this data set from the link which I have shown you from here. Okay, so I've mentioned the link here to get it from here. So when you run this, training will start and your model will be trained for 100 epochs, and after training, in your runs folder, let's open the runs folder here, train 2. Okay, so this is the folder which have the trained model. Inside this weights folder we have a best.pt and last.pt. Using this best.pt we can make predictions on unseen data. Okay, and here you can see the confusion matrix and the map values. Now let's test the model. Okay, so we have trained the model, custom model. Now let's test that model. So we are loading the pre-trained model, and here we are providing the video on which we want to perform testing, and then let's run it. Let's see the output. Detect, predict 6, and this fire. Let's open it. See, now our model is able to detect fire and smoke. So I've just trained this model for 100 epochs. Okay, so guys, this is how you can work with YOLOv9 through Ultralytics package, and I hope this video is helpful. Thank you for watching.